Okay, so another application of the dot product is for finding the distance between 2 points. So the setup is very familiar to previous ones. Imagine that you have a point P, x1, y1, z1, a point Q, x2, y2, z2. There's a position vector here. There's another position vector here. And then there's a, remember, just as we did on the plane, there's a relative position vector which we call PQ. The same argument holds, so PQ is just Q minus P, or really the difference between the position vectors. And it makes sense to call the norm of this vector the distance between the 2 points. So we can just define the distance between P and Q to be the norm of the vector PQ. And again, the point is that you can use dot product because this is just the norm, the square root of the dot product of PQ with itself. So just to do a quick example, because this is a very straightforward formula. So let's say that P is 135 and Q is negative 1, 1, 4. What's the distance then between P and Q? Well, let's before that, in order to find the distance between P and Q, we need the vector PQ. So PQ is just the position vector of Q minus position vector of P, or this is the same as really Q minus P. So it's negative 1, 1, 4 minus 135 which is just negative 2, negative 2, negative 1. Okay? And then the distance between P and Q will just be the square root of the dot product of PQ with itself. So it will be the square root of negative 2, negative 2, negative 1 dot negative 2, negative 2, negative 1. And that's the square root of, well, negative 2 times negative 2, that's 4. Negative 2 times negative 2, that's 4. Negative 1 times negative 1, that's 1. Oh, nice. 8 plus 1 is 9, so this is 3. So those 2 points would be a distance 3 from each other.